Alright, so I'm going to be recording again because the last time it didn't capture. So, what I'm talking about is Obsidian, which is a markdown software, and importantly for me and us, it allows you to visualize networks. So it has a graph function that I'm using now for a conlang. So this is Laita that I was commissioned to make by someone for a novel. And here are the entries to Laita. So most of these are words in Laita. Some of them are suffixes and prefixes. So you can see the suffix and everything that is derived from that suffix. So Ishamvam, Arsam, Mingsus, Ishasrin, everything that has in it is linked to So right now what I'm going to talk about is the linking in network and how to show derivations of words, but there is more to it than that. So this software is also pretty good for comparative purposes. So if you want to build a set of tools that will allow you to compare your conlangs to others and even natural languages, it's possible to do that. And then within Obsidian, be able to select conlangs of a similar type, or to look through every sort of arrangement of color terms, let's say, that you have, and find what you have done, which conlangs fall under that category, look at their color terms and find, for instance, what you haven't done, and then maybe use that for a different language. And it has potential also to organize the lexicon. So in the same way that there is WordNet, this is sort of, it's a network. There's software to access it. This thing organized by Princeton some decades ago now, to group words by their senses. So the word dog, for instance, has a sense of canine, and it also has a insulting sense, like dog, you wretch, you cur, you dog, all these things. And so there's at least two senses for dog. And then what WorldNet will do is, for everything that shares the first sense, so canine and dog, let's say, it will link those together. So there'll be a sense. It goes into, the synonyms are gathered into what is called a synset, and every word in that synset is grouped. And for the other sense, which is the insult, wretch and cur and dog are grouped based on sharing that second synset. So we can also do that in Obsidian, and that allows us to disambiguate our synonyms or near synonyms in the conlangs, and to keep track of our taxonomies. So something like color terms that break up a set completely into non-overlapping regions, divide semantic space in a non-overlapping way. And it also will help us with our loanwords. So the loanword part is the least developed. When we get to it, I'll talk about it, and you'll see how this can help you figure out what to loan. Let's say you have languages interacting. It's a region where culture is being shared and technology is being shared, and someone goes visit another land, and you're wondering what will they see, and of the things that they see, what will they need words for, what will they be using foreign words for, if, for instance, instead of their own. So we're gonna get there, and as a teaser, I'm just gonna show you. So here's what kind of the comparative side of Obsidian is going to look like. So this is a set of color chips, and we're going to be using them for every single language we have to sort out what the color terminology is. And so then that's a set of color chips, and this, for instance, is those color chips applied to a single language. So we have that down. That's the Berlin and K stuff. We're just going to ignore it for now. And with that out of the way, we're going to start. We're going to go back to Laita. Let's start with Laita. Alright, so zooming out, we have blue, orange, and green. And the blue is the lexicon entries, as I already said. And the large circles are those that have a lot of linkages. And this is all in the modern language. So there's a proto language, but I've suppressed it from the graph, and these are all modern language words. So these are the numerals, and this will be something like 20. And so these will be all the numerals formed using the word for 20. So like 21 in this language, 19, 18, 17, 16, 22, 25, and so on. And if you click on a word, I've already opened one. So Obsidian requires that the titles of the notes, the entries or notes, that they not be overlapping, and so I number them. But you see it came up here as something else, as Singatunum Uvas, and that's because you can alias with the real name of the term. But for uniqueness, the actual labels here are numbers for me. And so for each one, to make an entry, I have the words, I have pronunciation in IPA, I have definition, which for this one is a rather short definition, but it can go on, and you'll see more elaborated ones. And then what I do is I link it back to everything it's derived from. So what this means is the first word, Singatunum, is to feel similar by touch. So if you say this feels like tree bark, you would be using this seems like tree bark, and seems would be Singatunum. It's been a while since I pronounced light. I figure these all have a terrible accent, but that's just the way it is. And so then, so here I have linked to the word Singatun, which is to feel similar by touch. And I can also follow it, so this is the modern language, and I can also follow it back to Proto-Lita. So it was put together in Proto-Lita, but the Proto-Litan words don't have definitions, because that's just the way this particular project went down. It's the modern words that have the definitions, and the Proto-Lang just has like the derivations. So you can figure it meant roughly the same thing back then. But you can also have different definitions in the modern and the past. And if I go for the last word, uvas, you see here, this means modern times oil, and it also has a link to its Old Elvish form, which meant something similar. And what happens is, if we go back to Old Elvish, this form upas, we can find other words derived from it. So right here we have, in Old Elvish, lu, a prefix, and upas. And if we follow it into the modern language, we see it has become luvas, and or rather luvas. Luvas means slippery when used to refer to a liquid. So we can start with a proto-language form, and we can find everything related to it in the proto-language like this, and other things which have derived from it in a modern language like this. So we can go from a modern language form to other related modern language forms, and we can like trace the history of a word, where has it ended up, and what its ancestors are. So right now you're only seeing derivations that happened within modern Lita, but if I turn on proto-Lita, you're going to be able to see past and present. So here, what Obsidian does is allows you to suppress some things from the graph. So here I've suppressed proto-Lita and some things called reference, and I'll just force it to reload, and then we'll zoom out, and you see the graph now is massive. And so what's going on is that pink is the old forms, so sing was an old prefix, and blue is the current form, so is a modern prefix. And you can start with an old form, so sathaying, and you can see it gets rather busy when it's this many, but you can see it became sachting. So sathaying became sachting, and you can see that on the graph now that I've put everything on there. So yeah, and the prefixes themselves have a history usually, and you can trace it back. So alak became Allah, and here we have alangas, and well, this is the one downside is with this many, it's hard to find exactly where something came from if the links choose to put it far away. But yeah, Nala became Nala, and it also prefixed with sing in the past, and that became Singala. And if you want to know what Singala means, then it means to create or to cause to exist. So I'm actually going to take them all back off. So here we don't want reference and we don't want protolita. And then we're gonna go look at our graph again. We will again force it to load. Alright, so now this is only modern stuff. And so we're gonna talk about the second thing you can do. So you see orange and green. So here in orange I have, and the way we're doing that is Obsidian allows you to choose colors for different folders. So lighter is under one folder, and under lighter I have the words, some words here, and you see those are blue, and proto-lighter things are pink and purple. So let's remove this also. So these are things word order, and this is where, so you can have a folder specifically for usage notes, and this is markdown, so that's a usage note. This is also a sort of usage note to talk about the color terms, and you see I can paste images here, but I can't do much more. I can't do more than like bolding and underlining. There's no centering or really anything fancy, and that's a limitation of Obsidian that processes only markdown files. So the formatting is limited. It's not like Microsoft Word or anything. But what you can do is I can link example sentences here, and when I've linked an example sentence, I can do it morpheme by morpheme. So arsem mingsus is made of arsium, which means I eat it, ming, which means me, and sus, which means red currant. And then I have a plugin here that will show me when more than one term is sort of cross-linked often, and I'll show it later with the colors. But what this will allow is for me to go to a specific term and kind of figure out which terms are more closely related to it, as in they often are linked together. So esh is apparently often used in the same context as and what that means is that I might be, depending on the words, I might be tempted to make these into compounds in a future language. So if I find that let's say Ming and Sus, even though in this case it won't be true because Ming is gonna group with the verb, but let's say it were often the case that Ming and Sus were next to each other, and some of these statistics here showed that to me, I might say that Ming Sus will collapse and in the future become something like moose or moose or mingus, and that'll be like a new word in a future language coming from the collocation that I notice here using an Obsidian plugin called Co-Citations, or called Graph Analysis, that has Co-Citations in it. And right, so that's that. This is just showing how you can, how Lighten is pro drop and context sensitive, and you're allowed to drop things if you feel that would be obvious. Right, so that's it for Lighter, and I'm actually going to now talk about the color chips. Well, that's it for Lighter. These are Lighter's color chips, at least some of them. And I'm actually looking for some definitions for a second. Right, so that's the definition of a color chip, but it's done better in the future. So we're going to go to the future now. Alright, this is the future. And by the future, I mean it's the Obsidian I use for my personal conlangs. This is a descendant of that other structure. So this, what you see here, is a graph where each color is a different conlang. And what will happen is that these conlangs are all in contact, and so there's going to be borrowing. So a word here could be loaned to this language, and what that means is I'll be making a pink dot to represent the word in Otzi, and it will be linked just like how Lighten words had links to the Proto-Elvish counterpart. This Otzian word will have a link to the counterpart in the green conlang, as yet unnamed. And so you'll be able to see the history, and the langs that share the most words. Obsidian will pull them closer together because you can control the link strength, and it'll plot them close together, and you'll be able to see that. But what we're here for now is comparison. So this is an example of one language's color system. And in point of fact, this language is using the color system from French. So this is also like my interpretation of French's color system. And the terms don't show up there. But let's go to a place they may show up. Oh, this is not so bad. So this was like a journal conlang, or yeah. And so what it has is it has a 4-color system. And in this 4-color system, you can see that blues and purples were co-lexified, and a yellow and green is co-lexified, and then there's white. And if I were doing this today, I'd move these into red, and I probably will move them into red. But you can see at a glance the color system because of the chips. So here, a single color chip, and here a set of them. And I guess I just want to go over how we came up with the set. So I'm gonna have to open up some other websites to show this, because the thing is, you'll remember, I don't know if you know Berlin and K ordeal, but there were some studies in the past of people trying to figure out how do people think of color cross-linguistically. And so there was a set of chips that they would offer to people, and ask them questions, try to get them to assign it to a color or describe it with colors, and see how much other people can figure out what color is being described and things like this. But the sample space in the desaturated colors, what happens is at every hue angle, let's say there's going to be desaturated color version. So they have going from saturated down to nothing at every hue angle. But in the desaturated colors, there's not that much difference visually across hue angles. So we're kind of oversampling the desaturated space. And I want a nice batch that can describe how you, the speaker of the conlang, will describe everything you can visually see, but I want colors that appear visually distinct to be wide apart in my sample space, so that when I take a spaced out sample, I'll get one of each. But colors that are not visually distinct, I don't want to be getting multiples of them, because it's kind of pointless to have 6 and 7 of what looks like the same yellow. Even if using like RGB or hex or something, it comes out as evenly spaced. So there's here's an explanation of how color spaces work from someone who built an app for people to choose a palette for like a website. So for instance, if you, or graphs. So for instance, if you're a data scientist and you want to plot a graph and you have 5 categories and you want to make sure that all of them come out as looking distinct and know they're related, if the data really says they're not really related. So this will pick you even perceptually evenly spaced colors, and it will take into account the chroma and the lightness that you choose. So I could want exclusively high chroma colors, and it will still try to give me evenly spaced colors. And I could limit my hue angle, but with the constraints of my limited hue, it will still try to give me evenly spaced colors. And if I even narrow the lightness like that, it's not as good as it used to be because I have a narrow range, but that's what it's trying. And so here the thing is, the normal color spaces that we use don't have the property that choosing random colors from them leads to evenly spaced colors according to the eye. So these will find a color space that actually has that property, and I do believe they're like experimentally derived, like from when Munsell was making his chips. From what I understand, he did that by experiment, and that there might be like tests on these other spaces to make sure they have the property. But like there is one here, for instance, this like lab space that's meant to be perceptually uniform. So then if let's say this is what was random according to using hue, saturation, and lightness, and then when I plot it on like a space that's that that is perceptually uniform, they may end up not being so spaced out. I'm actually not sure if that's what that exact diagram says because I'm talking off my head right now, but that's the idea. So here, when you pick evenly spaced colors, they should look like you're taking a good sample. And what this R package does is it allows you to get your sample and get the hex values for your sample so you can then get color chips. So it'll map it from the space, one space, the normal spaces, HSL or RGB or whatever, put it to a uniform space, choose as far apart the colors as possible, and then give you back the RGB values. Sorry if that's like a long explanation for it. So we're going to R now, which is where I turned it. So using that idea, I got color chips. Using that idea, I got color chips like this. And so this is what I used to test out a conlang and say, how would you describe this color or that color? And you'll notice that I do have grays, but it's not like 50 of the same looking color, 50 of the same gray. And I have yellows, but I am able to have warm and cool yellows. So if a conlang were to separate these, I could tell, and this could measure it. If a conlang were to separate this, you can tell where the boundary between green and blue is because I have things on either side, and I have them in both saturated and desaturated forms for almost everything. And I put this all on a middle gray background. So the background of all my conlang stuff in the modern version of Obsidian is middle gray, so that we can do comparison. And let's do that later. And so here I'm just using the R package, and you can choose how many colors you want to sample and it will give you that amount. So we're actually going from 0 to 100 right now. And so in the corner there, those are the color samples, and the one that I use is what you got from 90. So this is deterministic, and if you run this, you'll get the same color samples whenever you put the same number. So every time I ask for 20, it's the same 20 colors that will come up. And I just went through them sort of by hand and made sure that I have saturated colors at what are likely to be the focal points. So I suspect, there's gonna be like orange, and if you have orange, you want the thing at the hue angle of an orange to be bright. Because this is trying to be uniform across value as well as chroma as well as hue, the thing that's at the hue angle for an orange might have come out to be dull. So there may be no orange. So you just got to go through this manually and make sure that the set you choose has something bright enough at all the points you think language is going to want to separate. So this is a bright yellowish green, which is great, but this orange is likely to be brown. And if your language like mine separates dull things from vibrant things, there's not really a vibrant yellow-orange here, so this wouldn't work. So I just go through until I find one that does work. And that's the deal. It's actually kind of neat because you get CMYK like if you start from the beginning. So here the very first thing at the beginning of the earth is just like dark and light, and they're both kind of cool. And then you get black separate from red and yellow, and as soon as you can it goes CMYK, and then it just builds up one by one like that. So I think that's cool. So anyways, here are 90 color chips. And now what you do is if you have a language that you're building, so for instance, I'm building this language's color terms now. I start out by picking the color chips and then I just move them around. So this is what's going to be for my light colors. And I just filter everything in here that I think the speaker would consider light. So this will eventually have a name. So instead of Untitled 5, it will be whatever this is in the language. And then what I do is I link them all together like this, so that at a glance I can see how the thing is divided. What's useful is if you are gonna go on a specific color. So this thing is distracting me because it's something else from something else I was doing. So if you're gonna go on a specific color, like this one, and you want to know now what is what is most similar to this color, right? So I have language A, but across all my conlangs, what's most similar to this? This plug in here, and I'm using the third measure. So each of these is just a measurement to figure out how closely two nodes are related. And what this one is based on is the number of shared items. So because each color is just a file, it's a picture. So I use the hue. I generated using an online tool a picture of certain pixels with nothing but that hue, and I just linked it in the Obsidian document. So anything that shares a large number of links to these exact colors will come out similar. And so if I ask it what's most similar, it'll give me another term for white in a different language. So this is wallow, which is like white in Tokipona, and I actually have Tokipona in here, my version of it. And this is Edna, which is a term for white in yet another language. And if I keep looking at the similar things, I'll just keep getting terms that are basically synonyms for white. You'll notice they're different, so they don't have the exact same semantic space because they're from different conlangs, but all of them have the trait of being in their system the one most similar to like white. And I can also find different ones. So if I go down here, the things at the bottom are gonna be terms for dark. So now I'm finding basically terms for black, and if I follow this around, I'm gonna get more and more terms for black. So this is a term for black in color system A, and it has colexified with it blue and purple. This is a term for black in color system B, and it's not as hue dependent because you see there are reds and greens here as long as they're all dark. But basically you can just follow the chain like that, so I can find similar color systems. What I have is also the Berlin K. So they postulated, okay, if you only start with what we'll call 6 basic colors, blue, green, yellow, white, black, and red, and we'll say that these come before any other colors in language. And they postulated like a chain of development, which I believe has been called into question. But if you don't believe in a chain of development from one to the other or disagree about the direction, I get the strong impression these are still the most salient colors to people's minds. Or that these are like naturalistic sets, naturalistic divisions to keep around. There's also kind of a thing where you can have, these are supposed to be basic colors only, but there can be non-basic colors. So in English there is green, but there's also lime, and lime is not a basic color because people generally consider lime to be a form of green. So if you have these in your conlang as the basic colors, you should just remember that you can also have other colors that are used. They're just not, they don't pass all the tests for basic color systems. So anyways, under each segment, I have listed every language I have that follows that. So this is a language that just has light and dark. So it would put white, yellow, and red in one place and green, blue, and black in another. And so when I have two languages that follow the same system, more or less, I can see it. And I can also see when I basically haven't used the system yet. So I only just started a black, red, and white one. This one is kind of a more maximalist system because it splits on hue and it also splits on chroma. Right, so, and then from a single color chip, I can tell, first of all, the similar color chips tend to be placed close to it. So just because of being linked in the same color terms, I have inadvertently sorted all the colors. But also, if I want to know what is this thing called in language X and Y, I have the list of things that use it. I can't find which value here gives that to you, but I know one of them does. So, oh right, I know. So this is Co-Citations, but what you actually want for this is backlinks. So Obsidian allows you to see everything that links to this document. And so, for instance, Anke links to this document, and that's because Anke is a color term in one of my conlangs that means more or less green. So green and yellow together. and kuf links to this, and that's because kuf is a term in a conlang that links cool blues and blues and greens and purples. So you can start with the color and find the terms, and you can start with the terms and find other similar terms, and you can start with the color sets and find conlangs that do similar things and things you haven't done yet. So that's what the comparative version of this is, and it doesn't work only for colors. It would work obviously for any sort of closed system where you can find exemplars and then just figure out how to sort them. So it would work for body part terms. If you had an image of the human and instead of color chips you would have dots across the body, so that you could determine in your conlang where is the line between arm and hand. And if the arm dots and the hand dots are actually grouped in one color term, that would be something you can tell, like me grouping this yellow with every other yellowish thing and all the greens, whereas another language might split them apart into 4 or 5, however many categories. Can use it with phonemes. So I did to download samples of all the phonemes, and then per conlang I'd be like, okay, the phoneme E, or rather phone samples, I guess just sound samples, and it'd be like the phoneme E, here are the sounds that E can surface as in conlang A, versus here are the sounds that a similar phoneme but slightly different will surface as in conlang B, and it doesn't have to be a complete overlap, and it would take your allophony into account. So this is comparative obsidian. The thing that's least developed, and actually one thing you should know about comparative obsidian is that the color sets have to be kind of isolated from the bigger description. So the word here, I'm gonna show in this one. So open sesame. So this is number whatever. Its real name is Miahe. So Miahe has this definition in terms of samples from color space. So it's clearly gray. Now under it, I would do something like this. Desaturated. That's its definition in words. And it could have other definitions like washed out, tired, if we just borrow from English for a second. These have to be separated from the actual color chips. So this is not where I put the color chips. I actually have the color chips linked to it in this file where they're always alone. And that's because the graph analysis plugin is gonna count everything in the file you're looking at when it counts similarity. And I don't want it to count my word-like definitions, because it will make this less similar to other things with the same color chips. And if I post pictures, as you've seen me do, and I definitely post pictures a lot, it will count those pictures the same as it counts the color chips and say two things are dissimilar when they're not, because you didn't use the same pictures to illustrate it. So the color chip is the cross-linguistic official standardized battery, and you segregate it, and then here in the definition of the word you put whatever you want. So that's the way I set it up. I'm going to delete these because it's not the real definition. Alright, cool. So now we're going to talk about the last thing, which is the vignettes, or rather which is the more definitional stuff. So I'm going to collapse the side stuff because I don't want them in the way. And we're going to go to something completely boring to look at, because we don't want to get distracted either. Alright, so now that we're looking at this boring thing and you're not going to pay it any mind, look to the side. And in particular, look under this that I just toggled. So, what are the types of information that we need to store when we're organizing a conlang, a lexicon? So we obviously need to store grammar information. And grammar information is like that thing on the other one where it talks about the word order in lighter. So how do you use the words? It's like a usage guide. Lexicon is like all our words and all our affixes. So lexicon is what was in this graph right here, all of the blue, and I count derivation of things as lexicon too. Scaffolding, I have scaffolding here, and what I put are like the example sentences, and like how I have to separate the color chips when I'm trying to do comparisons. I put the separated out color chip in scaffolding, and I put the word where the definitions will go like this in lexicon. Alright, and now we get to like the meat. So taxonomy is a meat. Whenever you have a closed class, like a semantic space, and you have terms that cover it fully. So for instance, there is no color out there that wouldn't be covered by one of these here color terms. So when you have something like that, I call that taxonomy, and I'll put this file, for instance, inside of taxonomy, and a body part system file with all the body part terms would be in taxonomy. If you split up your emotion terms into like a closed set, then that's taxonomy. If you split up technically the phonemes can even go in taxonomy. So anything that's a closed system that's meant to describe everything else is going to be in taxonomy. And now we have thesaurus. So thesaurus is like this. You have two terms. Just gonna give it, you have to come off and on again for the grade to kick in. So you have two terms, like on one word you have pleasantness, right? But pleasant in your conlang, you also have a word nice. And pleasant could be like nice to look at. And it could also be used for sweet to eat. So it's nice to experience it. And nice could be used for like good to others, and therefore it could be compassionate. So these words, so pleasant would be like a thing in lexicon. So I would open lexicon and I would take pleasant and I would stick it there with its definition, so it would have every definition. And then I would come here and let's say I called it pleasant, but this would be a term in the conlang. So here I'm going to be linking pleasant, and specifically I'm going to be linking the first definition, nice to look at. And I'm going to link it in such a way that the definition actually shows. And then I'm also going to link it under the actual name. So let's say we have this word here. I think this will do it. Yeah. So okay, that didn't do it. But in any case, we're gonna link it, and then we're gonna also have the title. This works. So just to remember off my head how to set it up. So we're doing it like that right now. And then for nice, I'm gonna do the same thing. So for nice, I'm gonna have to give it its own thing. We're gonna call it nice, and then we're gonna come here. We're gonna say nice, and then we're gonna try to link nice. We're gonna make sure to do it in such a way that the meaning shows. Alright, good. So now what I have is a thesaurus that disambiguates two similar words, pleasant and nice, but in particular it isolates the senses that they share, and it will not include senses that are more different. So this we can call it, it's a nice pleasant spectrum. But if one of them starts to mean something like good to eat, we won't put it here if it's not that comparable with the meanings of the other words. So this will allow us, if we have like a set of prepositions like in, at, on, and we're trying to figure out when do I use in and when do I use on, you'll be able to look at a full definition of in and a full definition of on and figure out in which context should I use one or the other. So this is like what WordNet does. So these terms here are the senses, the different senses for a single word, and this is what you'd call a synset, which is nearly synonymous senses of separate words being grouped together. So, right, and I no longer need these are for demonstration. And the next thing we're going to look at is the vignettes. So I think the vignettes are more useful for people doing word building and people who are going to be learning a lot of words. So here in vignettes, what will be, and isn't yet, but will be, a vignette is like a little scene or a moment. So if you're in the kitchen and you're cooking and you have the plant, so you have basil there, and you have your knife that you're using to chop, and you have the fire, the pot, the stove, the smoke, the countertop, and your mortar and pestle. So a vignette will be like, instead of this stuff about the R package, I'll have a diagram of the cooking scene, you in the kitchen. And we'll link to it each of those items: the knife, the tabletop, food, the smoke, the stove, the hairnet, and we'll give the conlang terms for each of those things. And if your people are known to be sailors, a vignette would be you on the ocean. So you'd have the waves, but only what you can see of the water from on the ship, because a vignette is based on the ship. You will have, your hands are running along the side of the ship. You can feel a rough wood, maybe even word for rough, if you just call that part rough as metonymy. And you'll have the sails and the mast and the waves that splash over the shore, but nothing on the water. So we're not talking about like the fish that live in the briny depths. We're just talking about like you can see glistening from the moonlight on the wave tops, and that you can see the color change when you're on the ship, and you can see blue water and shallow green water. And we're talking about like weather changes. And the reason is, let's say someone comes to speak as of your conlang, so they're like an intern, right? They're taken on the ship to learn the ropes, literally. A child-ish. No child labor laws in the pre-modern age, and let's say you said it there. And they go on the ship to learn the ropes. They speak a different language originally. They're going to be learning the ropes with people from your culture, because your culture is the master sailor culture. And it's like, what words do they actually need to learn from your culture? What words are they actually exposed to from your culture? And the answer is, those are going to be only, or most of the words that have to do with ship life. So it's going to be all the words from this vignette on the ship, and all those things I just mentioned about the mast and the sea and the ocean and port and starboard. Those are the things that they're going to learn first in your language and not in theirs, or that they're going to be using in your language and not in theirs. And so those are the things that they're most likely to loan. At least I think so. So all the things in your vignette are things that you should be looking at as potential loan words for someone that interacts with your culture in this environment. So if people are interacting with others from your culture when they're in the kitchen and learning from you, or when others from your culture are in the kitchen and speaking to them about things in the kitchen and they're trying to accommodate and use the same terms, then things from the kitchen vignette are what you're going to want to loan. And so basically like that. So the vignette is a collection of terms that are united from being in the same field or the same area in time and place. They are not a closed system. I'm not including everything to do with the ocean. And if there's basil, and basil is considered greens in your country, like how it's greens in English sometimes, I'm not including every color term. You're not going to be including like everything made of wood if you have a wooden pestle. And it's not a synset, so the things here don't share the same meaning. Like pestle and basil don't mean the same thing. So it's not like a thesaurus to disambiguate near synonyms. It's just like an experience. So these are all the words that come up during this one experience. And I think it would be a good nexus for things like this, where language A, the pink, is taking words from language B, the green. And so you're going to be taking words that are linked to a particular vignette. So because it's in Obsidian, the vignette would be here, and what you'd be doing is just like linking the words. And let's say this word is truche or whatever. It'll come up as Twitter actually if you link it in the correct way. So instead of untitled, because the thing right now is named untitled, had I given it the proper alias, it would come up underneath that alias. And so you'd have all of these, and then there'd be a node here, like this is a node with all the color terms of a particular language. There would be a node with all the things from a particular scene, and then you can link it. So basically everything underneath that node is just going to be mass borrowed into that other language, and then that's where they're going to get all their vocab, like all the ship vocab. Let's say they're going to steal it, and then you need a disambiguator, because let's say you borrow a term for the surface of the ocean when you sent all these people out to go learn on the ship, but you already have a term for ocean. So now we have the thesaurus comes in, where you put the two ocean terms, you work out all their senses, and then you gather the related senses and paste them all on one note in the thesaurus, so that you can look and learn, when am I going to use the foreign term for ocean, and when am I going to use, what does that actually mean now, and when do I use the home term for ocean? So right, those are the vignettes, and methinks this organization system has potential. And with that, we come to the end of our presentation.